So, we're going to start out and we are going to talk a little bit about how computers work and how computer programs work on a very basic level. The first thing we're going to look at is the parts of a computer and the basic functions in a computer program. So, to start off with, computers have something called inputs. This is how a computer takes information from the world, and it's kind of similar to like in humans, our inputs come through our senses, such as our eyes and our ears. What are some of the computer inputs? Things like your keyboard, your mouse, the touch screen on your phone. Your camera can be an input. Microphones, a game controller, a scanner. All of those things that are things that take information and send it to the computer. An output is how the computer displays or communicates this information. So, as humans, we communicate information by talking, or sometimes we use things like sign language, gestures, nodding, things like that. Those are examples of communications that we use without talking. Things like your monitor or your screen, headphones or speakers that let you listen to music, printers, all of those things are things that can be considered computer outputs. Now, again, just like humans, computers have something called memory. And this is how the computer remembers things, and just like how you remember things. And there are two different types of memory. The first one is called RAM. RAM stands for Random Access Memory. And you can think of this as the computer's short term memory. Things that are stored here that will disappear when the computer or the program is turned off. So if you think about your computer game, anymore, if you look at how many graphics and things like that computer programs have, random access memory, the RAM that you need to play a game like something like Fortnite, is that working memory. How much does it take for you to actually be able to play that game? The second type of memory is called storage. Storage is also referred to as the computer hard drive. This is the computer's long-term memory, where it can store information even when the power is turned off. So when you download that Fortnite game and you store it on your computer, that is stored in the storage. So then when you go to turn it on and use it, you're using the RAM memory. Now, the last main part of a computer is the processor. This is usually a small chip inside the computer, and it is how the computer processes information. If you've ever heard of the term CPU, CPU stands for Central Processing Unit. You can think of the processor as the brains of the computer. The faster the processor, the more quickly the computer can think. Now, the other day you saw several parts of the microbit when we had it out. Some of you didn't because the case was in the way. So some of these things you saw and some of them not so much. So just take a minute to look at the parts of the microbit. Can you point to the parts that you think are an input? What about the parts that you think are an output? How much RAM does a microbit have? See the CPU there at the top? Notice that they are in the same space. On the top left corner, you might also notice that your microbit has a Bluetooth antenna. This means that your microbit can communicate and send information to other microbits. Now that we know the general parts of a computer, let's talk a little bit about how they work. We're going to start small. You know the definition of a function? You probably do. You've probably heard it in math class. It is how the input to the it is how the input to the computer is processed. It is what we do with the input. So for example, x plus 7 is a function. Which part of this function represents the input? The input is the x. And what is x? Well, x is a variable, and that means we can make it be whatever we want. So we can put in different numbers for x. And then what are we going to do with those numbers that we put in as our input? We're going to process them. We're going to add 7. So adding 7 is the process. So let's just say that x equals 3. That's our input. We're going to take that x equals 3 and we're going to put it there in place of x. And so 3 is our input. We are going to process it by adding 7. So 3 plus 7 is 10. What if we change that variable to 15? So now instead of x equaling 3, x equals 15. So now we're going to take that 15 and we're going to process it by adding 7 to the 15. We're going to get 22. One more. What if x equals 8? We're taking that input, we're adding 7, we're going to get 15. So that is an example of a process or a function where we are taking an input and we're getting something out. So now conditionals are a special kind of processing. We're going to talk about these in a lot more detail later on. But basically, if something is true, then an action will occur. And this is just a special kind of processing. So for example, if someone is standing in this room, then you stand up. So you standing up is a condition if someone is already standing in the room. If it is sunny out, then stand on one foot. Else, turn in one circle. So this is an example of a conditional. If you are in the 7th grade, then sit back down. So this special kind of processing, this conditional, if this is true, that's the trigger. That's what causes the next action. So we've talked about the 4 main components of a computer. We have the input, we have the output, we have the processor, and we have the memory. That's the last one. Something else to think about, how many programmable buttons are there on the microbit? There's 2 or 3, if you remember kind of the secret one that we found the other day. That's going to be important here in a few minutes. And then we have different types of processing that a computer can do. We can do functions and then we can do conditionals. Those are kind of the big overarching things that we can do with a computer. So now we're going to look at how to code some things. We're going to do a very basic program today just to kind of get our feet wet. So what we'll look at is we'll look at what an algorithm is. We will write some pseudocode, and then we'll make our microbit smile. So take a minute and look at these steps. What do you think these steps are all a part of? You might be able to notice that these are common steps that people take when they're trying to get out of bed in the morning. But they're not in any order. So take a minute and on your note sheet, put these steps in an order that makes logical sense. Think about the steps that you might have to take in order to get out of bed in the morning and put those in order. So here's how I put my steps in order. You may or may not have the exact same thing. And if you don't, that's fine. The thing about programming a computer is that you do not have to have exactly the same thing as somebody else does. But some of these probably are in a specific order. Like if you get up, you're probably not going to throw the covers off after that. So this is what we call an algorithm. An algorithm is just the steps that the computer goes through. It's kind of the big ideas, the main ideas of the program. So we can also think of it as what we want the computer to do. Another term we want to introduce here is pseudocode. Pseudo is a prefix that means false. So this is literally the false code. And what it is it's code written out in plain English, which is not a language the computer can understand, but you, the human, can. So our first program is going to display a happy face on the microbit at some point and a sad face at another. On your note sheet, there's a place for you to write this goal and the outline for this program. So the goal for our program is to display a happy face or display a sad face at different points in time. So let's break down the parts of our program. We want an output of a happy face at some point in time. Remember that an output is what the computer is showing us, and we want the computers to show us a happy face. We also want an output of a sad face at some other point. So these are two steps to our program, and they both complete the goal of the program. Something else we might want to consider is that the program should do what we want when we first start it. Let's say that we want to control when the sad face appears and when the happy face appears. We don't want to do it to do it automatically. In this case, we would tell the computer that when the program starts, we want to show nothing on the screen. So when we start our program, we have a blank screen. And then we want to do something that outputs a happy face. And then we want to do something else that outputs a sad face. Now let's think a little bit more about the code itself. We know that we want the outputs of our program to be. Now we want to think about how to make that happen. Remember we talked a little bit about conditionals, that if a certain event happens, then the computer will do something we want. Let's say that we want to show a happy face when we press the A button on the microbit. So if the A button is pressed, then the microbit will show a happy face. We now have an input to tell the computer that when we want it to show us the happy face. So what could we do to show a sad face? There are quite a few different inputs on the microbit, but how about we keep it simple today and say that we want to show a sad face when the B button is pressed. So if the B button is pressed, then the microbit will show a sad face. This is what we mean when we say pseudocode. We are identifying our inputs and outputs and putting into an outline that any human can come along and understand. So now we want to think about how to actually make the computer understand. And this is what we mean when we say programming. We need to translate the human words into computer words because the computer does not understand human words. And just like with humans, computers can understand different types of languages. With humans, there's things like English and Spanish and Japanese and Chinese and German. There's all different kinds of languages. This is also true for computers. Here we have just a few logos of some of the different computer languages. Do you recognize any of them? JS is JavaScript, and the blue and yellow snake is Python. Both of these are text-based languages that programmers use to communicate with computers. Kodoo and App Inventor are both graphical user interfaces. You've probably been exposed to a little bit of Scratch, which is a block-based environment. Scratch is a little bit similar to the MakeCode platform that we're going to be using for the microbits. So let's start with a new program. Go into Classroom and click on the MakeCode link. You should see a page that looks like this. The first thing you should always do is sign in. It will pop up with the option to choose your Google sign-in. Pick that one. If you do not sign in, it's not guaranteed to save your work, and that will be tragic. So make sure you sign in. That should be the first thing that you do every single time. And then we're going to create a new program. So click on Start New Project. And you will get a button pop up that looks something like this. And you're going to name your project Happy Sad Face. So once you open up your program, you will have a blank workspace that looks like this. There are two blocks that pop up automatically. One is called On Start and one is Forever. For this program, we don't want something to, forever is just a block that keeps something going over and over and over again the entire time. We're going to get rid of that because we don't really want that right now. But if we look back at our outline, we do want the On Start button. Do you remember what we wanted to show on Start? We wanted to show a blank screen. So what we're going to do is we're going to come over here to Basic. So this Basic toolbar has a lot of pretty general things over here. We want the one that says show LEDs. And we want to put that in there. So what this means is that on start, we will show a blank screen because none of these LEDs are lit up. Now, if we click on this, for example, on start, now there's a button or there's an LED that's lit up there in the middle. Okay, and you can change this if you want, but let's leave it blank for right now. Now, one of the things that we do want to do, we want to make comments. Comments are for the humans, and they are your friend. And this is a pretty simple program, but we're going to get in the habit of writing comments in our code. To do that on the block, you're going to double click. So take 2 fingers and double click on your mouse pad. And you should have a little menu that pops up. Now, the duplicate option is very important. You will use that a lot. But right now, we want the add comment. And so what you get is a little bubble up here. And if you click on that, it gives you a place to type. These are comments, and these are for the humans. These are things that the computer is going to ignore, but might be really important for you as a programmer, especially when we start getting into more complicated programs. So what we're going to do is we are going to type a comment. So when the program starts, there will be a blank screen. Okay, so that's a comment. We'll click there. And so we can come back here and we can see this comment. We can make it bigger, right? So if we get really confused and we forget why we have this block of code, we can come and we can click on this. Oh yeah, I wanted a blank screen on the startup. Okay, so we do want to make sure that we are putting in comments. I will tell you that when I write code, I have more comments than I have code because I can't ever remember what I'm doing from one day to the next. So this is the first part of our program where we said we wanted on start, we wanted to show a blank screen. Now the other part, the second part of our program, we wanted to, when we press the A button, we wanted that to be our input. We wanted to show a happy face. So over here, if you look at these menus, over here we have an input. The one at the very top says when button A is pressed. Now you can change this to when button B is pressed and when button AB is pressed. Okay, but that's our input block. And what do we want to happen when we press the A button? We want it to show a happy face. Now we can come over here and we can make our own with our LEDs if we want. But Basic also has some pre-made icons. And if we click on it, I'm pretty sure there's a happy face right here. So what this particular thing does, on button A pressed, when we press the A button, we're going to show a happy face. Now over here on the left is a simulation. So this is actually a really good simulation. And actually, we don't even need the microbits really to be able to do a lot of this. That's just a perk. But if we come over here and we press the A button, now we have a happy face. So this is the first part of your program. So the next part of your program is to figure out how to make a sad face when the button A is pressed. Now, once you have completed your program and you want to turn it into Google Classroom, you will come up here to the share button. So this little arrow looking thing, this is the share button. You're going to click on that and your share project window will pop up and you have the name of your project. You're going to click on share project. That will give you a link right here and you're going to copy that link. Don't click on any of these buttons down here, just click on copy the link. And then what you're going to do is you're going to come over here into your Google Classroom. You're going to find the algorithms assignment. That's the one that this is. Okay, go away. When you come in here, when you look at this, you will see this is where the assignment is. Here's the link to the make code. Over here where it says your work, you're going to click on add or create. There's an option to link. So you're going to click on that. You're going to paste the link in there and click on add link. So just like you do a Google Doc or a Google Sheet or whatever assignment you turn in, you're going to do the same thing with this link. And then once you have it completed, you can turn it in. Okay, now here's a challenge for you. And by challenge, I don't mean optional. So here's the rest of your program. Go in and add a code so that a sound plays when the happy face appears, and add a code so that a different sound plays when the sad face appears. All right, so look through those menus in the make code and just kind of see what you can play with, see what you can find. All right, so add a sound for the happy face and add a sound for the sad face, and then turn that assignment in.